Alright, in this video I'm going to show a concave mirror with a close object, and we're going to do the ray diagram. Here it's a concave mirror, see it caves in the middle, and as a result, if you imagine parallel rays coming in, they would all bounce off and there would be some point where they all converge or where they all meet, and that is the focal point. If we extended this mirror and made it into a giant circle, there's the center of curvature. And for this ray diagram, we're going to do our standard 3 rays. We're going to look at where the first two meet. We're going to use that to predict what kind of image somebody looking at this would see. And then we're going to do the third ray to confirm the location of that image. So ray number 1 is going to go parallel to the optic axis, then bend through the focal point, it's a real focal point here, unlike our convex mirrors. So when this ray bends through it, oh, what was that? I'm going to try that again. So when this ray bends through it, it's real light bending through that location. So through the focal point. Something like, just make sure we have a long enough ray here. Something like that. Now the next ray is a little strange. The next ray, you would imagine usually what we do is we have a ray that's coming in through the focal point and it bends parallel. But here the focal point is behind the object. So we can't have a ray going through the focal point if it's going to head towards the mirror. That's okay, this isn't a big deal. What this really means in this situation, so again, this is ray number 2, through focal point, then parallel. So the way we handle this in this odd situation is we line up the top of the object with the focal point on this side like this. It seems like the ray is coming from the focal point, which it really isn't, but that's how we handle it. And then when that ray hits the mirror, because it is in line with the focal point on its initial angle, that means that that ray is going to bend. Oh, somehow I got a parallelogram. Let me try that again. That means that that ray is going to bend parallel. So through the focal point, well, not really. What we mean by through the focal point, like we did in the other one too, is in line with the focal point, and then that ray is bending parallel. So we have our 2 rays here, this one and this one. And what we see immediately with those 2 things is they are divergent. Divergent means that they are not coming together, that they're separating apart. And so those 2 rays are never going to meet. Now, the way our eye works is it assumes that light travels in straight lines. So when we have 2 rays that are headed away from each other, and our eye wants to figure out where the image or where the thing that created those rays came from. I don't know what that is. Hold on a second here. What our eye assumes is that those 2 rays came in straight lines. And so we can extend them back to where they came from. And when we do that, we get virtual rays. There's no real light there. It's just where our eye thinks the light should have come from. When we do that, we can see that there's a intersection back here that our eye must think was the source of both of those pieces of light. It's not real, it's virtual. It's a place where our eye assumes that object must have been if it was going to create these 2 divergent rays. What we can see in this situation is that that image is large, it's upright, it's a little further away than our object was, and this time, because it's not real rays of light converging in that location, it's virtual rays of light, we call this a virtual image. Sometimes a virtual image is defined as an image that could not be projected on a screen. And if we imagine putting a screen back where we see eye in this location, because this is a mirror, we could not project this image on that screen because there's no real light there. However, if we imagine looking into this mirror and trying to decide where that thing was that we're trying to see, because our eye is able to interpret those two divergent rays as straight rays, it imagines them straight all the way back to where they intersect and creates a virtual image in that location. And so this is the definition of a virtual image, and this is how we form one, at least using a concave mirror and a close object. The third ray, just to confirm or to be complete with this ray diagram, starts at the top of the object and goes through the center of curvature. Now what we assume is, since it's going through the center of curvature, when it hits the mirror, it's effectively hitting the mirrors at 90 degrees to the mirror. And so when it bounces back, it's going to bounce back straight along the same path that it was on in the first place. So here we're going to line up a ray going through the top of the object, hitting the mirror and bouncing straight back. Something like that. And again, this ray will be divergent from the other two rays, but if we extend it back, we can see that it predicts the location of the image in the same location as the other two rays. And so the third ray in this case helps us see that we have gotten our image location correct. Now I'm being a little tricky here that my drawing isn't exactly to scale or isn't perfectly straight. You should use a ruler when you're doing these things. But I think you can see from this video how to do the three rays. So that is a concave mirror with an object which is relatively close.